Hello everyone, my name is Praful John and I'm a student of International Institute of Professional Studies DAVV Indore. Currently I'm pursuing Masters in Technology in the field of Information Technology. This video is part of my assignment which contains solution to the test 1 which was conducted by Dr. Shaligram Prajapat sir. To begin with the video, we'll be discussing about the questions that were asked in the question paper. The first question is, suggest recent malware analysis techniques. The second up we have is, illustrate the public key implementation of RSA with P equal to 7 and Q equal to 11. We'll be discussing the answer of the first question, which is, suggest recent malware analysis techniques. Before we get started with the answer, we need to think of some key points which we'll be discussing about. The first one is, we'll be discussing about the definition of the malware. Then we'll be discussing about types and example of malware. And then finally, we'll be discussing the techniques to deal with them. So what is malware? Malware is a term used to describe malicious software that is designed to harm, disrupt, or gain unauthorized access to a computer system, network, or device. Malware can be spread through various means including email attachments, malicious websites, social engineering, infected software downloads, and more. Once malware infects a device or network, it can cause a range of problems including data theft, system crashes, data encryption, and more. Moving on to types of malware, an example of the same. Virus. A computer virus is a program written to alter the way of computer operations without permission or knowledge of the user. It can corrupt, steal, or delete data on your computer. One of the example is I Love You virus that spread in 2000 via email attachments. The second up we have is worms. It is a self-replicating program. Its main function is to infect other computers while remaining active on the infected system. One of the examples of worms are CodeRed. CodeRed worm is surfaced in 2001 and was able to infect hundreds of thousands of servers within hours. The next up we have is Trojan horse. It can enter your system by downloading an application that they thought was useful but was malicious. Once Trojan horse is inside your computer, it can do anything from recording your password by logging keystrokes to hijacking your webcam to watch and record your every single move. One of the examples of Trojan horses, the Zeus Trojan horse, which is a type of malware that is often used to steal banking information. The next up we have is ransomware. Example of the ransomware is the WannaCry ransomware attack in 2017, which affected more than 2 million computers in 150 countries. The next up we have is spyware. It monitors your online activities or install programs without your consent or to capture your information. FlexiSpy app can be installed on a target device to monitor its activities such as text messages, call logs, and location data. Next up we have is adware. Superfish adware was pre-installed on some Lenovo laptops in 2014. Protection strategies. Protecting against malware involves a combination of measures such as keeping software up to date, using strong passwords, avoiding suspicious websites and web links, using antivirus and anti-malware software, practicing safe online behavior, etc. Sandboxing involves running a program or file in a controlled environment to observe its behavior and analyze its effects on a system. Sandboxes can be used to identify and isolate malware and to study its behavior without risking damage to the underlying system. Memory analysis. Memory analysis involves analyzing the contents of a system's memory to identify malware that may be hidden or difficult to detect using other techniques. This approach can be used to detect malware that is designed to be memory resident, or to analyze the behavior of malware that is running in the memory. Automated static analysis. Automated static analysis involves analyzing a program or file without actually executing it. This can be done by analyzing the file's code, looking for known patterns and structures that are commonly used in malware, and identifying potential vulnerabilities or exploits. This approach can be used to quickly analyze large number of files and to identify potential threats before they are able to do harm. The next question we have is, illustrate the public key implementation of Raivesh, Shamir, and Edelman with P equal to 7 and Q equal to 11. The steps, here are the steps to calculate the same. First, we will be calculating the value of n, which will be equal to P into Q. In this case, we will be having it as 77. Since P equal to 7 and Q equals to 11, 7 into 11 will be 77. Now we will be calculating the totant of n, as in this case is phi of n equal to 6 into 10, that is equal to 60. Since we know that phi of n equal to P minus 1 into Q minus 1. Now we will be choosing an integer e such that e is greater than 1 and less than phi of n. And the GCD of e and phi of n should be equal to 1, which means e and phi of n should be the co-prime numbers. In this case, let's choose e equal to 7, since 7 and 60 has GCD equal to 1. Calculate the modular multiplicative inverse of e modulo phi of n, which is the private key exponent d. That is, d is the integer such that d into e mod of phi n equal to 1. In this case, we need to find d such that d into 7 mod 60 equal to 1. One possible value of d is 43. Now we know that public key is e comma n, which in this case is 7 comma 77, and private key is d comma n, which in this case is 43 comma 77. To encrypt a message m, we'll be using public key, which is e comma n. We can compute the ciphertext as c equal to m to the power e mod n. And to decrypt this ciphertext c, we'll be using private key d comma n. We can compute the original message m as m equal to c to the power d mod n. For example, let's say we'll encrypt a message m equal to 42. We'll be using the public key, which is 7 comma 77, to encrypt the message. So the ciphertext c equal to 42 to the power of 7 mod 77, which will give us 2. And now similarly, we can decrypt this ciphertext c equal to 2 using the private key 43 comma 77. We can compute the original message m as m equal to 2 to the power 43 mod 77, which will give us 42. By this method, we can successfully decrypt the message. I hope you learned something from this video. Thank you so much for watching.